I'm going to talk about electrical power. So, if you recall from the unit on energy, we learned that power is actually work over time. Okay? And we know that work is also the change in energy, or in this case, we've been talking about, potential energy of an electron. So, it's the change in potential energy over time. Okay? And we know that potential energy relative to volts is QE or QV, right? So you get QV over T, okay? And in the last video we learned what Q over T is. So Q over T is charge per unit time, and that's current, which is I. So we actually get, going through the whole derivation of it, we get P equals IV. So power is equal to current times volts, okay? Now the unit for power is a watt, okay? And a lot of times, if you are, talking about a piece of like an electronic equipment, right? We're trying to get power out of it in order to, fuel something else, right? So you're trying to get power to light up a light bulb. And so the power actually leaves the system, okay? And so the terminology that's used quite often is to say the energy or power dissipated from the circuit or from the electrical piece of equipment. And that's what you're trying to calculate here, okay? Now we can also calculate energy in terms, power in terms of resistance. So remember that we also have V equals IR, and now we have P equals, let me just rewrite it. P equals IV, okay? So if we wanted to, we could plug in, for V, we could plug in IR. So we actually get P equals I times R, which is I squared R, okay? So those are the two equations that you will see for calculating power. So that power equals IV, and that power equals I squared R.